Hello students, welcome back in physics classes. I hope students that your term 1 examinations were very good and you enjoyed your exams. Dear students, before exams we have finished our unit 7, that is properties of bulk matter, and now today we are going to start our unit number 8, that is thermodynamics. So let us start our unit number 8 class plus 1, that is thermodynamics, and chapter 1 means the first chapter name is first law of thermodynamics. Students, I know that few topics from this chapter you have already studied in your chemistry, so it will be a revision for you. Okay, but listen each and every term carefully and try to make notes along with video only. Okay, you can go through video for 2 to 3 times also for understanding, but I will not send you separate notes. You need to make video from these notes. I hope I am clear to you all. So let us begin. As I told you, the unit name is thermodynamics. Students, thermodynamics is a branch of physics which deals with the temperature change, means some properties of system will change with temperature, and this branch of physics is called as thermodynamics. As you know that the meaning of thermo means temperature, dynamics means change. So thermodynamics means change in temperature, means the properties of system will change with change in temperature or some other properties will change. Okay, so let us start our first topic of this chapter, that is thermal equilibrium. Students, as its name is suggesting, thermal means temperature, equilibrium means equal. So thermal equilibrium means two systems are said to be in thermal equilibrium with each other if they are at same temperature. For example, we are having two systems A and B. The system A is at 40 degrees Celsius and system B is also at 40 degrees Celsius. So you know students, if temperature is same, there will be no exchange of heat because the temperature is same. We know that temperature means heat always flows from low means cold body to hot body, but if both are at same temperature there will be no flow. So at that point the two systems means A and B are said to be in thermal equilibrium, means they are at same temperature, no flow of heat, no exchange of heat will take place. Okay, so zeroth law of thermodynamics is related with thermal equilibrium only. What zeroth law of thermodynamics state? Students, you must be thinking that the name of chapter is first law of thermodynamics, but we are studying something different, because before studying first law of thermodynamics you must know zeroth law of thermodynamics. Okay, so what it states? It states that if two systems A and B are in thermal equilibrium, now I hope you understood the meaning of thermal equilibrium, with the third system C, then the A and B must be in thermal equilibrium with each other. They must be in thermal equilibrium with each other. Okay, its example I can give you that for example A and B are separately friend of C. Okay, means a person is there C who is a friend of A also and who is a friend of B also. Then obviously A and B will also be friends with each other, is it or not? Okay, so same is here, that if A and B are separately in thermal equilibrium with system C, then A and B are also in thermal equilibrium with each other. To understand this, we can take this system A, B, C. A और B के बीच में जो wall है, that is adiabatic wall. Adiabatic wall you can understand in this way that no heat will exchange between A and B. Okay, इनके बीच में कौन सी दीवार है? Adiabatic means ना heat A से B की तरफ आएगी ना B से A की तरफ जाएगी. But the wall between A and C and B and C is diathermic, means heat can flow. Okay, so फॉर एग्जाम्पल हीट विल एक्सचेंज बिटवीन ए टू सी, ए से सी को आ सकती है, सी से ए को जाती है. इट डिपेंड्स अपॉन द टेम्परेचर. इफ ए टेम्परेचर ऑफ सिस्टम ए इज लेस, then heat will flow from C to A. If temperature of system C is less, then heat will flow from A to C. Okay, similarly C to B it can go, B to C it can go, but it cannot go from A to B and B to C because both are separated by the adiabatic wall. Okay, so students, heat can flow from A to C, C to A. Heat can flow from C to B and B to C. So obviously the heat will flow from here to there till the time their temperature will become सेम. फॉर एग्जाम्पल B का टेम्परेचर हो गया 30 डिग्री, तो हीट तब तक फ्लो करेगी जब तक C का भी सेम टेम्परेचर ना हो जाए. सो फॉर एग्जाम्पल इफ B अटेन्ड 30 डिग्री, C टेम्परेचर विल ऑल्सो बी 30 डिग्री. अब B के A के साथ चेंज हो रही है, A टेम्परेचर शुड ऑल्सो बी 30 डिग्री. So that means B is in thermal equilibrium with C, A is in thermal equilibrium with C. That means A and B are also in thermal equilibrium with each other. Okay, that means if two systems are in thermal equilibrium with the third system C, then they must be in thermal equilibrium with each other. I hope you are getting me. So now there are some definitions which are very important related to thermodynamics. So let us start. First is thermodynamic system. Thermodynamic system, it is the assembly of large number of particles. System, you know, I told you so many times that system means assembly of particles. Okay, so it's the assembly of particle having certain value of pressure, volume and temperature. If you have paid attention in your chemistry class thermodynamics, then you must know that there we are dealing with only these three variables especially, that is P, V and T, means pressure, volume and temperature. So assembly of this large number of particles having certain value of pressure, volume and temperature is called as thermodynamic system. Thermodynamic variable, students, these pressure, volume and temperature means P, V, T are known as thermodynamic variable. Equation of state means, equation of state you have studied, ideal gas equation is called as equation of state. So ideal gas equation is PV is equal to nRT, but for 1 mole of gas N will be equal to 1, so it is PV equal to RT. Thermodynamic process, it is the process in which the thermodynamic variables changes. Okay, and this process is of 4 types and these are very important. Isothermal, iso means same, thermal means temperature. So the thermodynamic process in which temperature remains constant is called as isothermal process. Second is isobaric process. Bar is the unit of pressure, so keep in this way in mind that isobaric process means the thermodynamic process in which pressure remains constant. Isochoric in which isochoric process in which volume remains constant, and adiabatic process, just now I told you, it is the thermodynamic process in which no heat enters or leaves the system. So these are very important definitions for exams. Next is you can see this portion of board, that is PV diagram. Okay, so students, P means pressure, V means volume. So pressure and volume diagram means the graphical representation of the system with the help of 2 variables P and V. So you can see I have drawn here 2 diagrams and both diagrams are exactly same. Just pause the video and see the difference. That what is the difference between 2 diagrams? I hope you get it. The difference is of this arrow. In this, the arrow is downward side and in this arrow is an upward side. Downward arrow is showing that A is initial position, B is final position, means volume is increasing. At A the volume was V1, at B the volume is V2, means volume is increasing. So this is called as expansion, means pressure and volume diagram is telling us about the state of the system. And in this diagram, arrow is in upward direction, means it is going from B to A. Earlier volume was more, now volume is less. That means decrease in volume, and decrease in volume, the process is called as compression. One is expansion, one is compression. Okay, so these two terms are also very important. Keep in your mind. Okay, so students, I hope you understood this. Don't forget to comment in comment box for your attendance. Okay, and do write these in your notes notebook so that you can learn it later for exams. Okay students, don't forget that a worst pen is better than a best memory. Okay, so do write for learning in future. This is enough for today. Thank you. Have a good day.